Okay, Honors Algebra 2, we are going to do Lesson 10, which is on page 20 of your notes, curve fitting with polynomials. So we want to start off with a little exploration. And so it says, for each function and its table of values below, complete the following. First, find the differences in the terms of the y values. And it's important that you go left value minus right value. Then find the differences of those differences, repeat until the differences are the same. How many levels of differences did it take for the differences to be the same? So I'm going to show you what that means. But first, let's make sure we note that the x values for each of these functions listed are increasing, or it doesn't matter if they're increasing or decreasing, but they are at regular intervals. Regular or consistent intervals. So let's look at that first. And what I mean by that, intervals, is that here, looking at A, 0 is the first x value, then we add 1 and we get 1, add 1, 2, add 1, 3, add 1, 4, add 1, 5, add 1, 6. So each time we went by 1. The same is true for these x's. We increase by 1 each time. Add 1, add 1, add 1. And so in order to do what we're going to do here, it is very important that the x's are at regular intervals. I want to just see here. For the next one, it's the same by 1. Now, if we were, you can see my email there. It's interesting. Okay, if we were increasing by 2 each time, that would be fine. Or if we were increasing by 100 each time, that would be fine. But the important thing is that x is consistently increasing by the same amount each time. And after you check that and make sure that's true, then you can go ahead and do what we're going to do here. So what we want to do is find the differences in terms of the y values. So we're at step 1 here. So I'm going to go left minus right. 5 minus 3. Subtract those. I get 2. Again, 3 minus 1. Subtract those. I get 2. 1 minus a negative 1 gives me 2. Excuse me. All right. Negative 1 minus a negative 3 gives me a 2. Negative 3 minus a negative 5 gives me 2. Negative 5 minus a negative 7 also gives me 2. And so it says we did step 1, find the differences in the terms of the y values. Then find the differences of those differences. Repeat until the differences are the same. And already right here, the very first step, the differences are the same. They're all 2. And now the question 3, how many levels of differences did it take for the differences to be the same? It only took 1 level. The first row was the same. All right, let's do that for the next one here. So again, always check, make sure your x values are increasing or decreasing by the same amount. And now I'm going to go subtract my y. So I have 7 minus a negative 4 makes 11. Negative 4 minus a negative 9 makes 5. Negative 9 minus a negative 8 makes a negative 1. Negative 8 minus a negative 1 makes a negative 7. Negative 1 minus 12 makes negative 13. 12 minus 31 makes negative 19. And you can see in this row, these numbers are obviously not the same. So looking at step 2, it says, then find the differences of those differences. Repeat until they are the same. So now we're going to do it again. 11 minus 5 is 6. 5 minus a negative 1 is 6. Negative 1 minus a negative 7 is 6. Negative 7 minus a negative 13 is 6. Negative 13 minus a negative 19 is 6. And there we have it. They are the same. Yay, rah. And so we can stop now. And how many levels? So then question 3, how many levels of differences did it take? It took 2 levels. So it was on the second row they were the same. All right, one more here. Again, make sure all your x values are increasing by the same amount. So each time we're increasing by 1. So it's consistent, so therefore we can do this. So I'm going to do 32 minus 15 is 17. 15 minus 6 is 9. 6 minus a negative 1 is 7. Negative 1 minus a negative 12 is 11. Negative 12 minus a negative 33 is 21. Negative 33 minus a negative 70 is 37. So those are obviously not the same, so we continue. 17 minus 9 is 8. 9 minus 7 is 2. 7 minus 11 is 4. Negative 4, sorry. 11 minus 21 is negative 10. 21 minus 37 is negative 16. Again, those are not the same, so we continue. 8 minus 2 is 6. 2 minus a negative 4 is 6. Negative 4 minus a negative 10 is 6. Negative 10 minus a negative 16 is 6. And there we are. And this was the third level. The third row, they were the same. And so what pattern do you notice about the number of differences? Well, this one right here was a third level, and this is a third degree. This one above it for B was a second row or second level, and it's a second degree. One level, first degree. Isn't that kind of cool? So what we can notice here is that the number of differences is equal to the degree of the polynomial. Okay, so let's complete each statement. If the function is linear, which means if it's linear, it has a degree 1, then the first difference will be the same. Let me get a different color here. If the function is a quadratic, which means it's a second degree, right, then the second differences will be the same. If the function is a cubic, which means the degree is 3, then the third differences will be the same. If the function is quartic, which means the degree is 4, then the fourth differences will be the same, and I'm just going to write etc. because it can keep going. So this time now, example 1, what we're going to be doing in this unit is we are going to take data, and we are going to find as much as we can about that polynomial. So you are not going to be given equations here. You are going to have to find the equation, or if you can't find the equation, you're at least going to describe the polynomial to me. So for this last unit, or lesson 10, we're going in the opposite direction. You have to tell me about the polynomial. Okay, so for example 1, all we have is the table. We do not have the equation. So we need to find out, well, what type of function is this? And so the first thing we do, again, is we check our x values, and we make sure that our x values are increasing by a consistent number. So each number, like 4 plus 2 is 6, plus 2, plus 2, plus 2, plus 2. So the x values are consistent. And so since they are consistent, we can use our finite differences. That's what these are called, by the way, finite differences. I don't know if that's on there anywhere. Okay, so for our finite differences, we do -2. You can grab a calculator for this because these are now decimals, so, you know. -2 minus 4.3 gives me a -6.3. 4.3 minus 8.3 gives me a -4. 8.3 minus 10.5 will give me a -2.2. 10.5 minus 11.4 gives me a -0.9. 11.4 minus 11.5 gives me a -0.1. So we know it's not linear because those numbers are not the same. So we continue. And I'm going to run out of space here. But negative 6.3 minus a negative 4 is a negative 2.3. Negative 4 minus a negative 2.2 is a negative 1.8. Negative 2.2 minus a negative 0.9 is a negative 1.3. And then we do the last one, and we get a negative 0.8. And again, those numbers are not the same, so we know it's not a quadratic. So now we keep going. Negative 2.3 minus a negative 1.8 is a negative 0.5. Negative 1.8 minus a negative 1.3 is a negative 0.5. Negative 1.3 minus 0.8 is also a negative 0.5. So there we have the same number. And that was our third level. So A, use finite differences. When it says use finite differences, this is what we're doing right there. It says use finite differences to determine the degree of the polynomial that best models the data. Now notice it says that best models the data because we have very limited data here. Right? We only have 6 points on this function. There could be a whole bunch of other points, and we don't know what they are. But given the information we have, the polynomial that best models that data is it would be a cubic. Third degree. Because it took us 3 times to get our finite differences the same. All right, next. It says B, find a polynomial function for the data. All right, so now to do this, you're going to pull out your graphing calculator. And so let me pull mine up, and I am going to tell you how to do this. This is a new process. I think I have instructions on this as well, and I will pull that, post that on Google Classroom for you. But let me pull up my calculator right there. And then I'm going to pull up a little Word document right there so I can write our instructions. All right, so the first thing you want to do is, in order to do this, let me clear out of this. Clear. Second quit. There you go. Okay, you are going to first put in your data. So then to do that, you hit Stat. Interesting. And then you hit Edit. And you put in your values. L1 column will be your X's. L2 column will be your Y's. So let me do that. Stat. Edit, enter, L1. So I'm going to put into L1 all my X values. So the first one is 4, 6, 8, 10, 12, and 14. Let me just point out that remember I said that the X values have to increase by a standard amount. That is true when you do the finite differences, when you do that subtraction thing. That is not true when we enter the data into our graphing calculator, because our graphing calculator is getting the whole ordered pair thing. But when we do finite differences, you've got to make sure it's the same. All right, and so now we're going to go to L2. Did I not get 14 in there? Yeah, I got to get 14 in there. Okay. Now we're going to go to L2. All right, and so now for L2, I have -2, 4.3, 8.3, 10.5, 11.4, and 11.5. So check your data, make sure everything's accurate. All right, so all your data's in. So we did that. Oops, squiggly. All right, and now we're going to do Stat, Calc. Let me get that going here. stat, and I go down over to calc. And now if you look at that list under stat calc, you can see all these these are all different types of equations. We have number 4 is a linear equation. Number 5 is a quadratic. Number 6 is a cubic. Number 7 is a quartic. Number 8 is another linear of a slightly different form. Number 9 is the ln, which is the natural log, which you have learned already. So if we keep going down, on the next one, 10 is exponential. And A is a power. So all these equations, you know, we're just going to start easy. I don't think we've done this before. So what we're going to do now to we already determined back here, we put this information in our notes in A, and we found out it was a cubic, didn't we? So that means, pull up my calculator again, I know that this data here that I put in, stat, edit, right there, that data, we already said that data is going to give me a cubic. So now, I did this, I know it's a cubic from step A, so I'm going to go here, and I'll do stat calc, enter. Oh, I didn't mean to do that, so let me clear that. Stat calc. All right, I want to go to number 6 here, because it is a cubic, which I determined from A, my finite differences. So I'm going to move my cursor down to 6, and I get a cubic. So I move down, I go to proper degree equation, and I hit enter. I think we have done this. We did this for natural log and everything. So I have my X list is L1, my Y list is L2. I don't want to store it at this point. I just want to calculate it, and I hit enter. And there it is. So the answer then would be A is 0.0104, B is negative 0.475, C is 7.108, and D is negative 23.5. All of those go into this right here. And so now I'm going to write that down on my notes. So I say Y equals, and I'm going to round everything to the hundredths, 0.01x cubed minus 0.48x squared plus 7.1x minus 23.5. And then now question C, use the function to predict the y value when the x value is 16. So the question is, if x is 16, what is the function? So to do that, I'm going to go back to my calculator here, and I did not store this. So what I need to do is store this equation. So again, I go stat calc, go down to my cubic, enter. But this time I want to store, and remember to store. You go down to store, right there, store reg equation, and you're going to hit, I don't know how to make my thing different, you're going to go vars, and then you're going to go y vars, enter, enter. So I'm here, my cursor's at store, I go vars, I move over to y vars, I hit enter because I want it to be a function, and I'm going to save it to the y1 equation spot, and I hit enter. All right. And then I'm going to go down here to calculate and hit enter. And there's that same equation again, but it should be stored in y1. And there it is. And then to find my answer, I don't know why move this down. There we go. Okay. Then to find y1, what are we looking for? y1 at 16. So basically we are looking for y1 at 16 when x is 16. And now my pen won't write, of course. And so what I'm going to do on that now is I'm going to go, first I quit out of this, second quit, and I'm going to hit vars, go to y vars, and I want my function, y1, enter, and then I put the parentheses in there. I have to actually put those parentheses in there. And you hit enter, and you get the answer 11.3. So you'd say y1 of 16 is 11.3, and there's your answer. All right, so let's do another one. I think this is the last problem. So we're given the table below. So the first thing we do is by hand, we want to find out if this is what type of equation this is. So I'm going to first check my x values and make sure they are changing. When I do finite differences, you have to check x values to make sure they're standard, which they are. Okay, so for example 2, question D, not sure why that's D, it should be an A, but anyhow, the first thing is to use finite differences. So that means that is manual. You know, we do this manually. No calculator except for to help with our subtraction. And when you do that manually like that, you are going to have to check your x values and make sure they go consistently. And they do. They decrease or increase by 3 every time. -6 to -3 to 0 to 3 to 6 to 9. You're going by 3s. So we're good. But just always be sure to check those x values. And now we're going to go ahead and do our finite differences. And so we take -9 minus 16, and we have -25. 16 minus 26 is a -10. 26 minus 41 is a -15. 41 minus 78 is a -37. 78 minus 151 is a -73. So obviously those aren't the same, so we do it again. -25 minus a -10 is a -15. -10 minus a -15 is a +5. -15 minus a -37 is a 22. -37 minus a -73 is a 36. Again, they're not the same, so we continue. -15 minus 5 is a -20. 5 minus 22 is -17. 22 minus 36 is a -14. Again, they're not the same. Do it again. -20 minus a -17 gives me a -3. -17 minus a -14 gives me a -3. And so there finally we have the same number right there. So that means 1, 2, 3, 4. It was the fourth row that gave us the same number, which means this is a quartic, or a 4th degree. So now we know, that's the benefit of the finite differences. Now we know what type of equation we're going to get. And now E, which should be B, is to find the function. That means we are going to use a calculator. And we're going to enter the data, this data, into our calculator, and then we are going to find the 4th degree, or the quartic, polynomial equation. Okay, so let's do that. Pull up my calculator. So the first thing I want to do is I want to go here, and I want to delete this because that was the last problem. So second quit. No, that's not the right thing to do. Clear. There we go. All right. And now I'm going to go to Stat, Edit, and I have all my old data. So I'm just going to go over that. I have a -6. I'm putting in my x's first. -6, -3, 0, 3, 6, 9, And there we have it. Now I go over to my y's, put in my y values. So I have -9, 16, 26, 41, 78, and 151. Make sure all your data is good and accurate. All right, and then we go to stat, but this time we want to go over to calculate. We want to go down to a quartic, which is number 7, a quartic. I'm going to hit enter. First, before we store it, let's just see what the equation is. So I hit enter, and there are all my coefficients for my quartic. Make sure as you do that all your, that you're really dealing with the quartic there, and you get the equation -0.0015 x to the 4th plus 0.1142 x cubed plus 0.2917 x squared plus 3.1389 x plus 26. Let me go over here and write that down real quick. So the answer is y equals -0.0015 x to the 4th plus 0.1142 x cubed plus 0.2917 x squared plus 3.1389 x plus 26. Now, if you look at the problem above, I only rounded to the second place, which would be right here, the hundredths place. But if I would have rounded here, that would have been a 0, and that would have taken out my quartic. And so that is why I chose to take this all the way out to 10,000ths place, 4 decimal places. And so then once I have to do that for my first term, I just want to be consistent in all my other terms and take everything to the 4th place. Okay, and now f. Use the function to predict the y value when the x value is 24. So we are looking here for the function at 24. So I go to my calculator. Now I know I didn't store that, so now I'm going to go back and do it again. Stat, calc, go down to my quartic, hit enter, but this time I want to store. So I go to store and I hit vars, y vars, function, y1, and now I go down to calculate, enter, and now I can check, and there's the equation, the function right there in y1. All right, and so now to find the value, I'm going to quit this, and I'm going to, just starting from a clear screen, I go vars, y vars, function, y1, put my parentheses in. I want to know what the value is at 24. y1 at 24, enter, and I get 1336. And so therefore, back here, use the function to predict the y value when x is 24. So f of 24 is 1336. And there you go. All right.